And number 36, this is a piecewise function. My apologies for not using a ruler. This is my g of x, 1/2 x plus 1, just graphing a straight line. Now, to graph these, I need to graph the line y equals 2x plus 1 for all x less than or equal to -1. So I'm going to graph the line 2x plus 1, but I'm going to start at -1. What I'm going to do is put in 2x plus 1 in my calculator. I'm going to go into my table, and I'm going to plot all of these points that are less than or equal to -1. So then I get this ray. I'm going to do the same thing for this parabola, but they want you to do it for all x's greater than 1. So I have 2 minus x squared in my calculator. I go to table, and now I'm going to plot all of these points that are greater than 1. Excuse me, greater than -1. Now, when you're plotting the point -1, 1, because of this greater than symbol, what we're going to do is we're going to use an open circle. It has to be an open circle because remember, in order this to be a function, the vertical line test should only pass through one point. This open circle says, like, hey, you can't include -1 because at -1, you're using this line. Okay? How many values of x satisfy the equation? So I'm going to answer that question. There are one value, and that's that value right here. Explain your answer using evidence from your graphs. We could say 1 because the functions intersect on the graph one time. In number 37, we're talking about a system of equations involving cupcakes and brownies. Now, during the school year, you may or may not be like me where you say like 3c plus 2b. In this case, they tell you what they want the cupcakes to be represented by, and that's x. So even though you're saying 3 cupcakes plus 2 brownies was $19, you have to say 3x plus 2y equals 19. The same for the second situation. 2 cupcakes plus 4 brownies equals 24. You have to say x's and y. So these are the 2 equations we're going to focus on. I am going to put my work over here and get these in y equals form in order to graph these. Taking both equations and getting them into y equals form, I come up with the 2 equations. I'm going to plot this one first. This is the 2x plus 4y. It looks a little bit easier to work with, so I'm going to start at 6. I am going to go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Here's my line for this equation. Now for the 3x plus 2y, I'm going to start at 9.5, and I'm going to go down 3 over 2. Down 3 over 2. Down 3 over 2. Down 3 over 2. And then you get this solution. This intersection is the cost of 1 cupcake and 1 brownie. So it looks like we're at about 3.5 on our x, and we are at about 4.25 for our y. So again, we don't want to say as a point. We want to interpret our answer. Also, don't forget that we need to label our lines when you have more than one on the graph. This is a habit that I need to break. I need to start doing this. Okay, so 1 cupcake is 3.5. 1 brownie is $4.25. Now, looking at the official scoring, it looks like you are allowed to communicate with the grader that you did this in your calculator, okay, as long as you communicate, I used, the second calc menu, and then I used intersect. And got 3.5, 4.25. Remember, as long as you're explaining how you got something, we're not, a lot of these problems aren't looking for one, only one way to solve. We're looking for you just to explain how you got it. Okay, so in conclusion, one cupcake is 350 and one brownie is 425. Thanks for watching.